Good evening, friends. Let's look at another problem from Project Euler, which is max path sum. So to understand the problem, let's go to Project Euler and take a look. So the problem reads as this. By starting at the top of the triangle below and moving to adjacent numbers on the row below, the maximum total from top to bottom is 23. So here is an example. So the numbers are arranged in the form of a triangle and you start from 3. So you go to the row below, you have got two choices for you to pick. Could be either 7 or 4. And if you choose 7, again in the row below, subsequently there are two choices to pick, which could be either 2 or 4, and the same is applied for the option 4 and 6. So the problem is stating that choose the path in such a way that the sum obtained by traveling through that path is the maximum. So the ones that is highlighted in the red. So this is the path that for this example is yielding the maximum sum, which is nothing but 3 plus 7 plus 4 plus 9 is 23. So once we understand this problem, the question asks us to find the maximum total from top to bottom of a bigger triangle. So let's go to the PowerPoint and try to understand this problem a little better. So we will try to see some small cases and get an intuition for understanding why this problem is first of all difficult. So I have given a small arrangement of numbers, the same kind of a triangular structure, and it's just 1 to 6, right? And there are three levels, right? So 1 being in the first level, 2 and 3 being in the second level, and 4, 5 and 6. So if I start at 1, then I can go to 2, right? It's one of the choice. And for 2, there are two more choices, right? 4 and 5. So I have enumerated it here. So 1 plus 2 plus 4 is 7, or instead of 4, if you pick 5, it is 8. So on the other hand, instead of picking 2, let's say you pick 3. So if you pick 3, again, for 3, there are two choices, which is 5 and 6, and it is 1 plus 3 plus 5 and 1 plus 3 plus 6. So basically, to get an intuition, we have listed down in a brute force way all the possible paths, and if you see the total paths possible, 4 ways possible, and one of the way yields the maximum possible sum, and which as we could see is 1 plus 3 plus 6. So let's look at another example where the number of rows or the number of levels, that would be the right word here, and it is nothing but the numbers from the example, and here the levels are 4. So again, if we start in the same way, you start from 3, and the first option you pick 7 in the second level, and for 7 I pick 2 in the first option, and for 2 there are two options, 8 and 5. So which is nothing but 3, 7, 2, 8, the sum is 20, and 3, 7, 2, 5, the sum is 17. And instead of picking 2, let's say you pick 4, and if you pick 4, there are again two choices, 5 and 9. So 3 plus 7 plus 4, so 4 is your choice instead of 2, and you can pair it up with 5 and 9 in the last row, last levels, which would yield you a sum of 19 and 23. And instead of picking 7, let's say we pick 4, and in the same way these are the sums that you could get by choosing the path 4. And instead of choosing the 4 at this level 3, let's say you choose 6, and these two are the sums that you could get by traveling through this path. And basically these are all the possible sums that you could obtain in a brute force way by traveling through all the ways, and the number of ways that are possible for a tree that is of level 4 is 8 possible ways. So I think you would get an intuition here for the problem that if the number of levels in a tree is basically n, there are 2 power n minus 1 ways, right? So we can go ahead and prove it by induction or anything, but I think you get that intuition, right? So let's not get into any formal proof, but the intuition is except for the last level, right? Because at this level, there is every node is on its own, right? There is nothing that we could do, but for every other level except for the last level, there are two options for us, right? either the left or the right. So in that way, if we are going to enumerate all the possible ways, there are totally 2 power n minus 1 ways. And now I think we will understand why this problem is hard to be solved in a brute force way, because if n is say 100 or 200, then 2 power 99 or 2 power 199 is a very big number, and even if it takes a millisecond to evaluate the sum of one particular path, to evaluate 2 power 99 or something, it's going to take years. So I think clearly we understand why this problem is particularly difficult. Okay, now let us look at a clever bottom-up construction, right? So which is going to help us overcome the problem of brute force. Okay, so let's take a simple example. So let's take again a 3-level tree, right? So if you look at the node 2, there are two possible choices that you could travel to from the node 2. Either you could travel to the left and reach 4, or you could travel to the right and reach 5. Let's say, but you can take only one of the one, right? So what is the one that you will take? You will take the one that is 215, because the problem is you want to take the root which is going to yield as a maximum sum. So it doesn't bother how you reached 2, but once you reach 2, the maximum sum can be obtained by pairing it up only with 5, right? So this is our intuition, right? So this is the clever trick that we are going to apply. So irrespective of the way how you reached a particular node, you take the root which is going to yield the maximum sum by pairing it up with the child which is going to yield the maximum sum by joining with the parent, right? So let's do this reduction, right? So if we apply this reduction, so for there is going to be two childs, right? So the left child being 7. How do we get 7? Because if from 1 you take the root 2, the maximum sum that can be obtained by taking the root 2 is 7. So by pairing 2 and 5 is 7. And if you take instead of the left child root, let's say you take the right child root, which is 3. So then maximum possible sum that you could obtain by traveling to the right is 3 being paired up with 5 will yield 8, and 3 being paired up with 6 will yield 9, and we pick the max of it. So 3 and 6 will be the max, which is 9, and hence you have got 9 here. So now 1, if it is going to get paired up with the left child, the sum is going to be 8, and 1, if it is going to be paired up with the right child, the sum is going to be 10, and we apply the same reduction logic again, and we get a maximum possible sum is 10, which is nothing but traveling the route 1, 3 and 6, right? So this is the clever bottom-up construction that we are going to apply, and this is going to get the solution in a linear way instead of the 2 power n minus 1 brute force way, right? So this is the clever trick that we are going to apply. So let's get into the implementation details, right? So from the diagram, it would be very clear that tree would be an obvious data structure, but we can do even more simpler, right? So I will just try to tell, like instead of using a tree data type, a tree is a very good data type to model this problem. It goes very well with the diagrammatic representation that we have shown in the before slides. But just for a quicker implementation, a two-dimensional matrix is perfectly fine, right? So we can implement the similar operations that we want to do by exploiting the tree data structure can be done by exploiting a two-dimensional array. So take the same example, and we have arranged it in a two-dimensional array exactly like this. 3 being in the topmost row, and 7 and 4 being in the second row, and 2, 4 and 6, 8, 5, 9, 3. So this is exactly the example that we saw in the project Euler. So now let's start from the row above, which is the n-1th row, right? So you start from the n-1th row. So 2 can be paired with the left child 8, or 2 can be paired with the right child 5. So which is the best pairing that is going to yield the maximum sum? So 2 plus 8 is 10 and 2 plus 5 is 7. So we know that 2 plus 8 is the best possible maximum sum that we could get, and the pairing that we will go ahead with is 2 and 8, right? So similarly for 4 and for 6, if we do this, right? So this is what we are going to get. So we are reducing the problem size by one level. So the best possible pairings that you can get by coupling at each level, right? So 2 with 8 and 4 with 9 and 6 with 9, right? So this is the best possible sum or the maximum sum that we can get by pairing with the last row, right? So let's apply this reduction again now to this particular row, right? So now let's apply this, and what we get is the maximum pairing, right? So 7, when it is paired with 10, it's going to give 17, and 7 and 13 is 20, which is the maximum possible value, and 4 and 13 is 17, and 4 and 15 is 19, which is the max here. So now 3 has got two choices to pair up. On the left it is 20 and on the right it is 19, and the maximum sum that can be obtained is by pairing with the left, which is 23, which is what we saw it in the Project Euler website, right? So with 3 reductions we have solved this problem, right? So what exactly we did, for every cell, right, in the row starting from the n minus 1, we just computed the maximum possible value that could be obtained by pairing that particular cell's value either with the left child or with the right child. And how did we capture that? Just by a grid manipulation or an array manipulation, right? So this one, so if I of I comma j is this particular cell, then I plus 1 comma j is the left child, and I plus 1 and j plus 1 will be the right child, right? So this one is going to yield us the maximum possible sum, right? So let's go and let's take a look at the possible implementation, right, of this particular problem, right? So let me stop here. Let us look at the implementation of the idea that we just discussed. So I have a text file, ut2 count path. So it is nothing but the example from the project Euler 374246859 in their respective rows, right? So this is the text file that we will give it as input to the program, and here we have the program, right? So to this program, these are just the input output mechanics. So we just get how many rows are there in the triangle, so that we create a two-dimensional array of that particular size, right? And we just get the file as input from the standard input stream, and we just assign the values to the respective grid cells, right? So this is just the input output mechanics, and let's go to the method, right, which is computing the max path. It's very simple, it's very straightforward, as we saw in the demonstration of the PowerPoint, right? So we take the grid as the input, and it's just that you start from the last but one row, and for each element in that row, right, apply the reduction, right? How do we apply the reduction? So for each element we compute the maximum sum path that could be obtained by pairing it with one of the two possible neighbors, right? So here is just like we are starting it from the n minus 1th row, which is the last but one row, and we are going till the topmost row, right, in the reverse order. And this is nothing but every single cell row wise in that particular row, right? So we are just computing the best possible sum that could be obtained, which is nothing but grid of I comma j is nothing but the max of what would you get by pairing that particular cell with the left child, or what is the sum that you could get by pairing the element with the right child, and whatever yields you the max of the sum, you pick the max of it, right? And just iterate through the loop, and whatever is remaining at the end of this reduction in the element 0 and 0 is going to be the maximum possible sum that could be obtained, right? So let me just run this. So we are going to run this, the number of rows being 4, we saw in this example, and we are just giving that as input through the standard input stream, and the maximum possible sum that could be obtained is 23, right? So I hope this program helps, and you could run it with the bigger triangle from the Project Euler problem and would figure out the answer for you. Thank you for listening in, and we'll meet in the next video next week.